Good morning, my dear students. Mr. Bassam with you. After you have studied how to get the multiplicative inverse to any matrix 2 by 2, today I'm going to explain how to solve any linear system by using Cramer's rule. You can solve any linear system consists of 2 variables or 3 variables by using Cramer's rule. If you have any linear system consists of 2 variables by using Cramer's rule. A1x plus B1y equals C1, the first equation. A2x plus B2y equals C2, second equation. This linear system consists of 2 variables, A1, x and y. These the coefficient of x and the coefficient of y. Cramer's rule depends on how to get the determinant of the variables of x and y. First step, D equals A1, A2, B1, B2. The second step, you get dx equals dx means you have to cancel the coefficient of x and put the absolute value c1, c2 and leave b1, b2 without a change. After you get dx, you can get dy equals, here you get dy, so you have to cancel the value of y, coefficient of y, and put c1, c2 and a1, a2 without a change. After you get the determinant of the variables and the determinant of x and the determinant of y, you can get x by dividing dx over d and y equals dy over d. Now, I will give you a numerical example to be clear for you. If you have linear system in 2 variables like this, 5x, the first equation, minus 4y equals 2. The second equation, 6x minus 5y equals 1. The first step, you have to get the determinant equals the coefficient of x vertically, -4 and the -5. Cross multiplication will be equal 5 times -5 minus 6 times -4, here -25 plus 24, -1. The second step, dx equals, here 2, 1 instead of the numbers of x, and leave the numbers of y, -4, -5. 2 times -5 minus 1 times -4, here -10 plus 4 equal -6. Here dx and here d. The third step, dy dy equals here 5, 6, the coefficient of x, and 2, 1. You put the values of absolute values instead of the coefficient of y. You will get dy cross multiplication 5 times 1 minus 2 times 6. Here 5 minus 12 negative 7. After you get the three values of d and dx, dy, you can get easily x equals dx over d equals dx negative 6 over negative 1 equals 6. Also y equals dy over d will be negative 7 over negative 1 will be 7. Then the solution set of this linear system x, 6 and 7. You can easily satisfy with these values by substituting the values of x and y in the two equations. You will find that these values satisfy the equation 5x minus 4y equals 2, 6x minus 5y equals 1. 5 times 6 minus 4 times 7 equals 2. 6 times 6 minus 5 times 7 equals 1. Now it is clear for you. If you substitute with these values x and y, 6 and 7 in the two equations, you will be sure that your answer is right. Other example, my dear students. If you have linear system 5x plus 4y equals 12, 3x minus 6y equals 24. As I have explained, you can get d, the coefficient of x, 5, 3, 4, and the negative 6. Cross multiplication 5 times negative 6 minus 4 times 3, here negative 30, here negative 12, negative 42. Dx, the second step, 12, 24, and 4, negative 6. Cross multiplication 12 multiplies negative 6 minus 4 times 24, here negative 72, here minus 4 times 4 16, 6 carry up 1, 4 times 2 equals 8, 1 equals 9. The answer will be negative 6 plus 2 8, 9 plus 7, 16. Now, it is clear for you, you evaluate the determinant of the variables, negative 42, and the determinant of x equal negative 168. Now, you can get the values of dy equals 12, 24 instead of y, 5, 3 x, cross multiplication 5 times 24 minus 3 times 12, here 5 times 4 20, 0 carry up 2, 1, 12, 120 minus 36, 4, 8. Now x equals dx over d and y equals dy over d. X equals the value of dx negative 168 over negative 42. Negative 168 over negative 42. The answer will be 4. So y equals dy 84 over negative 42. The answer will be negative 2. Now the solution set of this linear system x and y, x equals 4 and y equals negative 2. I think, my dear students, this is clear for you now how to get the solution set to any linear system consists of two variables by using Cramer's rule. Cramer's rule depends on 3 steps. The first step, how to evaluate the determinant of the variable of x and y. The second step, dx, and when you get dx, you have to cancel the variable of x and put the absolute value. And when you get dy, you can cancel dy and put the absolute value. After you get dx and dy, you can divide dx over d to get the value of x, and also you can get the value of y by dividing dy over d. By the same way, if you have any linear system consists of 3 variables, you can get also the solution set to this linear system by using Cramer's rule. But before I start how to solve this linear system, first you have to know how to evaluate the determinant 3 by 3. If you have any determinant 3 by 3, A equals A1, A2, A3, B1, B2, B3, C1, C2, C3, C3. This matrix contains 3 rows and 3 columns. To evaluate this matrix, put plus, minus, plus. This is rule, plus, minus, plus over the first row. And A1 lies on the first row and the first column, so cancel the first row and the first column. The remainder will be B2, C2, B2, C2, B3, C3, minus B1. Use the first row, the elements of the first row. The first element, A1, cancel the row and the column. The remainder will be B2, C2, B3, C3, minus B1. Minus B1 lies in the first row, second column, so you can cancel the second row, first row and second column. The remainder will be A2, C2, A3, C3, plus C1. C1, the last element in the first row, you can cancel this row and this column, and the remainder will be A2, C2, B2, A3, B3. Here you can do cross multiplication, and also in this matrix and in this matrix, multiply before A1, multiply B1, multiply C1, and get the value of the matrix. Now I'm going to give you numerical example. If you have A equals 410, first row, negative 9, 3, 4, negative 3, 8, 1. The rule plus, minus, plus. 4, the first element in the first row. Cancel the first row and the first column. The remainder will be 3, 4, 8, 1. Minus 1. Minus 1 lies in the first row and the second column. So you have to cancel this row and this column. The remainder will be negative 9, 4 and negative 3, 1. Plus 0. Cancel this row and this column. The remainder will be negative 9, 3, negative 3, 8. Here 4. Cross multiplication as you studied before. 3 times 1 minus 8 times 4. Here minus 1. Negative 9 times 1 minus 4 times negative 3 plus 0. Negative 9 times 8 minus 3 times negative 3. Here 4. 3 negative 32 minus 1. Negative 9. Here plus 12 plus 0. Whatever here, the answer will be 0. 0 multiply any number inside the bracket, whatever, it will be 0. Here negative 28 multiplies 4, negative 116, and here negative 3 plus 3 multiplies negative 1 will be minus 3. The answer will be negative 190. Now, if I give you other example, evaluate the value of this matrix 2, 1, 7, negative 5, 6, 0, negative 4, 3, 1. By the same way, plus, minus, plus. Here 2. Now I think, my dear students, that clear now for you to cancel the first row and the first column. The remainder will be 6, 0, 3 and 1. Minus 1. Cancel this row and this column. Negative 5 and 0. Negative 4 and 1. Plus 7. Cancel this row and this column. Negative 5 times 3 minus 6 times negative 4. Here 2. Six minus 0 minus 1. Negative 5 minus 0. And here plus 7. Negative 15 plus 24. Here 12. Here negative 5 multiply negative 1. The answer will be plus 5. Here plus 7. Negative 15 plus 24 equals 9. Here 12 plus 5 plus 63. 3, 5, 8, 0. Carry up 1, 7. The answer will be 80. This is the value of the determinant. Now, when I give you any matrix 3 by 3 and I ask you to evaluate the determinant of the matrix, it is very easy for you now to get the value of any matrix 3 by 3.